What is actually meant by accuracy with pressure sensors? And how do inaccuracies, as in deviations from the desired measuring result, come about? In a pressure sensor, the error is indicated when the value of the output signal does not correspond to the value of the measured pressure. And because that's not so easy to see or explain, let's take an abstract example. A simple children's height chart in increments of 10 centimeters, here represented by colored blocks. Based on this benchmark, the three most important accuracy-relevant factors for pressure sensors will now be explained. The 0-point error describes the deviation of the start of the measuring range from its set value. It arises when the chart has been set too high or too low. As a result, the whole scale shifts and all the measuring results will deviate from the actual value by exactly this value. The span error occurs between the 0-point and the full scale value. It arises when the distance between the individual divisions is constant, but constantly wrong. An example: the graduation marks were labeled with 10 centimeters on the rule. However, the separation actually corresponds to 11 centimeters. At the beginning of the scale, this error is of minor importance, but it adds up, and from a certain size, it is noticeably significant. The non-linearity describes how crooked or nonlinear the measured characteristic curve is. On the chart, the intervals are then sometimes too short, sometimes too long, or just right. The deviations are therefore uneven or nonlinear, which makes the measuring result sometimes too high and sometimes too low. And how do the three errors just described affect the measuring process in the pressure sensor? The sensor characteristic curve describes at how much pressure which output signal is issued. The 0-point error shifts the sensor characteristic curve in parallel. The span error affects the slope of the straight line. And nonlinearity turns the line into a curve. In practice, of course, all three measuring errors described may occur simultaneously. For individual measuring points, this can strengthen the errors or they could cancel each other out. The interplay of these and other errors, such as hysteresis and non-repeatability, is colloquially referred to as accuracy. For each VICA pressure sensor, you will find a list of the individual accuracy-relevant information in the datasheet. Thus, you can easily choose the right pressure sensor in accordance with the accuracy required for your measuring task. If you still have questions, we are happy to assist you in selecting the right measuring instrument for your accuracy requirement.